will talk about actually the DIDs or decentralized identifiers and our new feature in SDK, the DidWeb method. So actually we talk a lot on my videos about the DIDs, what the DID is and so on. So I try to summarize on this actually IPython notebook together with some general information. So if we talk about the DIDs, so it's mean that yeah, it's practically the core of the self-sovereign identity, and it's allow us to build the identifiers that is unique, persistent, cryptographically verified, and actually this decentralized identity, it could describe the person, device, or any kind of entity. So what it's about. So first of all, we need to understand a couple of things about the DIDs, that it's just globally resolvable identifier that actually as a result of resolution will give us the DID document. So you could go in details in the writing that I prepare here. But if we oversimplify the things, so every DID method represented as a one big global string. For example, here we have the DID for the DTLM, and it's a URI schema, so it's compliant with the URI. So URI start with the schema. So in this case, the schema is the DID. Then we have something magical that we explain later in a minute called the method. And after semicolon, we have something special that here we have the parset. So that's easier to follow. Yeah. So the DID itself, it's this string. It's contained the schema, it's contained the method as you see, and it's contained the identifier. So identifier, it's something that follow after the semicolon of the method. In a case of DTLM, DIT could contain the parameters and queries. So this behave as the regular URI. So we described this in my previous video about how to create wallet, what happens when we create the wallet, so you could reference to it. But here the main idea that we have this global identifier, and this global identifier, the main purpose of it, it's already the identifier that you could use to express your identity. But the main thing that it's resolvable, and it's resolvable to the something that called the DID document. So we have the example of the DID document, by the way, here. And as you could see, the main purpose of the DID document is just distribute your public keys, and have some authentication information about these public keys. So that's the way how you could cryptographically prove the ownership of your DID, that you just distribute and allow to resolve your public key, and you could sign something with your private key and then prove that you own the DID. But the own idea of the DID is that it's global identifiers, distributed identifiers that have the cryptographically way of proving the ownership of this identifier. And it's a really important thing. So I already described in a brief some magic like methods, but DIDs actually have something called the DID actions. And DID actions, it's actually, if you keep it simple, it's 4 actions for the DID. And for sure, it's the creation of DID. We describe how we could create the new DID. Quite often we could meet something or that called anchoring. Anchoring is more specific for the DID methods that it's on blockchain. So in this case, it's a way how you connect the identifier, so this magic string, with the DID document. So and it's called anchoring. So you anchor the DID identifier to the DID document. And it's usually the part of the creation that you somehow generate the DID document and then anchor this DID document with this identifier on chain. So next thing is the resolution of DID. So it's what I described you, that you have your identifier here and you have a way how to resolve it to the document. So the process of resolution is how you exchange the identifier to the document. And for sure the updating, it's not supported by all the methods, by the way. But it's quite important how you could update the DID document, how you could rotate the keys. If you're looking for some really secure DID method, it's the really should have the updating mechanism. The activating, it's really rare. I would say that majority of methods do not implement it. It's a way how you could say that your DID is not exist anymore. And I mentioned some magic about the DID method. So what the DID method is. So if we get back to the DID identifier, after the schema, we have something called method. You could see it here. So it's the DTLM. And actually method is quite simple thing. Method is describing how all these four operations, or at least some of these operations, actually work. That's it. So it's super simple. So it's just describing how all these operations or operations that available for the DID method works. And yep, that's the main purpose of the methods. And it's a couple of hundreds of the methods in the internet, and they quite differ. For example, here we have the example of the DIT element that are self-contained. For example, we keep the document encoded in a initial state, so it's quite fast to resolve. It doesn't require blockchain. It's self-contained. It's I would say that it's almost autonomous DID method, so it's quite useful. So it's the example of the DTLM, and for a long time it was our default method for the SDK. But recently we add the support of the DITweb. DITweb is quite interesting DIT method. So as I mentioned, it looks like dit.semicolon web, so it's described that it's a web method. The specification is available and stable, and it's in a quite up-to-date state, so it's a widely adopted method. And the simple idea of this method, it's quite cool, that the main security mechanism and main distribution mechanism, it's not the ledger, but it's a website. So you just host your DID document somewhere on the domain that you own, and it's enough actually for resolution. So the resolution is extremely simple. It will go to the domain and will retrieve your DID document. So let's say that it's a lot of discussions if it's safe or not, and it's a lot of pros and cons in this method. So the obvious pros of this method is super easy to scale, so you don't need to use any kind of third-party systems. It's extremely fast because you just need to fetch the document from the domain. So and it's fit really well to the enterprise and organizations that owns their own domain. Because, for example, if we have the affinity.com, we own the affinity.com, so we could trust that the document that hosted on the affinity.com is really belongs to the Affinity, because Affinity have the control on this. And it's almost autonomous identifier, because we don't use any third-party dependencies. We're not dependent on the ledger. We do not depend on anything. We just depend on the hosting that hosts our document. So the cons on the critic of the DITweb actually is quite simple, that the main security mechanism is based on the DNS ownership and the website ownership. So in theory, the DNS records could be reassigned, and they could be hacked. So we don't have the cryptographic correlation between the identifier and the document, because, for example, in case of the DIT element, your identifier actually, this one, cryptographically correlate with the document itself. So that's the part of the mechanism that make, for example, DTLM secured. But DTWeb doesn't have this actually. So that's the one downside, that the DNS could be reassigned and actually your website could be hacked. So be careful. So how actually to implement and support the DTWeb in our SDK? It's extremely simple. If you follow in my videos, that we just need to create the wallet factory and then obtain the API key. So it's not here because it's the sensitive information. If you want to have the API key, you could always use the Affinidi CLI, or you could use the Affinidi extension. So here you could create the Affinidi account and actually specify your email, obtain your API key. So please install the Affinidi extension to Visual Studio Code. It's a quite useful thing, so it will allow you to get the access key. But what we should do, we should, let's say, prepare the options, and we have two new options here. So first of all, we should define in advance where we want to host our DIT method, and we should calculate the web domain out of the location of DIT method, and we should specify that our DIT method actually it's the web. So you see here we have these two parameters. So how we calculate actually the web domain? First of all, if we just specify the domain, it will be hosted on some well-known location. So if you will just specify the volant.github.io, it will take a look to the volant.github.io.well-known /JSON. But for example, that's the place where our nice notebooks hosted as static web pages, and unfortunately we want to specify that it's SDK notebooks. Yeah, so that's why what we are doing, first of all, we specifying the domain, and then after the semicolon we specify all additional passes that lead us to the DID.json. So in our case, it's the volant.github.io semicolon SDK notebooks. I already made this special exercise. So first of all, if you don't know, we have this lovely website right now, so it's publicly available. It's host all our notebooks as static web pages that you don't need to actually do anything. You don't need to run Docker. You could read it. You could copy paste the code. You could copy paste the examples. So it's practically the same as notebooks that I keep here, but it's not runnable, but it's quite nice to be read actually. So use it, give your feedback. I will be glad to hear more what you like in this or not. But let's get back. So what we need to do, we need to specify the web domain, we need to specify the DIT method. What's next? Super simple. We create the wallet, we specify our options, and we specify our super secure password. Please really use Bitwarden password generator or any kind of password generator to use the strong passwords, but in our case it's good enough for the demo. So, and now our wallet for the DIT web have really special property. It's called the DIT document, and it will give you the document back. And as you could see, it's specify our domain and all of the things that have the signing key and recovery key and all of the things. So super simple. So now we should do the a bit of job that we get the content of this document property, and we should go and host it somewhere. So in my case, I will host it as a part of my book. So I will just put it as a static file, and it will be published. If you want to reuse for sure and be able to sign the credentials and so on, you should store in some secured storage like Bitwarden or whatever the encryption seed. Please don't share publicly your encryption seed. So to unlock the wallet, you need your encryption seed and password, and you could remind yourself how to do it here. So it's an open wallet, and then you specify the options, then you specify the seed and password. So we don't need it, but it's just nice to have. I want to have this value to be able in the future, for example, to sign credentials with this published DID and whatever. So now we go and host. I already make my homework, so I published the version of the book. So I will add the video on top, but in general it will be here. So as you could see, we have the SDK notebooks and then dit.json, and it's the same content that we actually get from the property. So what we could do with it? We could actually right now do the absolutely normal things as for the SDK. We could create the verifiable credentials, we could sign the verifiable credentials, we could actually verify the credentials that we created. So it's absolutely the same thing. So right now I'm doing the little exercise that will create me the credential, and as you could see, we use the dit web here as the identifier of the holder, and as far as it's self-signed, so you see that sign and sign credential, so it will contain the issuer. So you see that it's quite compact. The issuer is the same. It's the DID web volant.github.io at SDK notebooks. So yep, it's absolutely valid, and as you see, it have the signature, so you could validate this credential, you could sign the credentials, and right now we have our dit web that available online, and we could use it in our next examples to do all the credential operations, do the verification process, and so on. So please, we have absolutely the same in a more user-friendly way. You see, we could copy some values from here. We have all the code examples and so on. So this Jupyter books is much more user-friendly than just Jupyter notebooks. So just visit the website and you could read any kind of content. For example, the content, we already have the videos and the content about the how to create the wallet and all other things. So it was it that I was keen to share with you. So we have the new DID method. It's super cool. It's based on the hosted DID docs in a public websites, and yeah, that's it. Please subscribe to my channel. If you have any questions, ask them. I will be happy to answer, and I wish you the good day.